Hi everyone, my name is Tsaddiyq Morbeth.
And my name is Priyal Patel.
And today we're going to be talking about genetic engineering as a controversy. Genetic engineering is the altering of the genetic code of an organism. The organism could be a human, a plant, or even an insect. Anything with a genetic code can be genetically engineered. With this technology, different traits of an organism can be altered. One of these traits could be the size of a fruit, another, the height of a human. It could also be used to make us immune to certain things. This controversy is important because it has implications for the future of medicine and agriculture, arguably two of the most important elements of society. Both elements can prolong human life, improve the quality of life, or destroy society depending on who you ask. Ethicists claim that genetic engineering can limit children's autonomy. This is because some think that parents may try to give their children desirable traits that they find advantageous. This pushes children in a certain direction that they otherwise may not have gone had they never had any genetic modification. They believe that genetic engineering, or in their specific argument, genetic enhancement, should not be done at all. They use the Nazis' values and extreme views as a comparison. In an article titled, "Arguing for and Against Genetic Engineering," a column writer, Charles Colson, claims that British medical researchers plan to use genetic engineering to get rid of autism completely. He believes this will lead to eugenics, and that this path will lead us to trying to form a master race. Ethicists claim that it is necessary to establish clear guidelines and regulations. An article by Science Oxford Live says that these guidelines should address questions of fairness, access, and societal implications, ensuring that gene editing is used in a responsible and ethical manner. Ethicists ask that some future actions include careful study and analysis that will include potential risks. One question that ethicists will continue to ask is whether or not the proper precautions are taken so that this technology does not get out of control. Another stakeholder in this controversy, scientists, claim that genetic engineering and genome sequencing are the future of medicine. There are many diseases that are so complex that we can only hope to treat them and maybe slow down deterioration. So scientists argue that with genetic engineering, we can hope to eliminate the disease before it even manifests. This will be a new age of medicine, along with precision medicine. Precision medicine tailors certain treatments for people's genomes because medicines can affect people differently. As for what scientists believe should be done about genetic engineering, the responses are very diverse. There are two types of genetic engineering, somatic and germline engineering. Somatic engineering only affects the patient, and germline engineering affects future generations. It is thought that we should stick to somatic engineering, as the effects of modifying germlines are more complex than we can currently handle. It is also widely agreed upon that in any type of genetic engineering being done, there needs to be tight regulation. The He Jiankui incident is an example of what can happen when there is not enough regulation. He genetically modified 2 human embryos to make them HIV resistant, but could have possibly given them some other issues by doing so. Some steps that were thought to enforce a strict use of genetic engineering are keeping track and monitoring people who have access to the technology, although this is not always possible. Certain scientists also believe that biases against genetic engineering will slow down its progression, and we will lose out on the many benefits that come with it. The argument that is brought up is, if not genetic engineering to prevent illness, where will medicine go?
So for the third stakeholder, we're going to talk about religious groups. So science and religion do not often mix due to the tension between the fact and belief. There must be a basis of addressing the issue with genetic engineering without the involvement of religion. Religion affects the way a person thinks on a day-to-day basis. It affects the majority of their decisions. The main issue stems from the question if this is playing God or contradicting the idea that we are made in God's image. Specifically referring to the Christian religion, people are accountable to the Maker, which is God. There is a conflict when deciding when a defect is worth looking into. What makes a defect important enough to alter? There is a fear that the human gene pool could be affected in which people would no longer be considered people, but there is no criteria for what that would look like. If humans are altered to be smarter than everyone else, would they still be considered humans because it did not happen naturally? If they are no longer humans, they are no longer preferred in the afterlife. Altering the gene pool could also change the image in which God is seen in the future generations. One of the major views for a Christian is to prevent or relieve suffering. The intervention of gene altering should only be used to prevent a disease or alleviate pain. This is different from modifying an individual's characteristics for an already healthy person because it did not help them, because it is not helping them because of suffering, but out of selfishness. There could also be a disruption of balance among living creatures that were created by God. So after discussing the stakeholders, we found how the different stakeholders impact genetic engineering and its controversies. Genetic engineering is the future, but if it lands in the wrong hands, its impacts could be detrimental. Altering genetics of something other than human does not have a necessarily negative impact, but altering the human genetics goes against so many morals and beliefs. Many religions believe that God has chosen a person's lifespan, and if genetic modification could change that, then they would be against it. Parents may also push for their child to be the best and make them the strongest and smartest. This would be unfair for other parents who could not afford it or simply believe that it is wrong. This is a huge gain for scientists, though, because it is a major breakthrough for many that could redirect the future. It would allow for so many new opportunities.
After thorough research on all of the stakeholders, I feel that there could be a middle ground found between all of them in order for the technology to still grow without it interfering with their beliefs. So for ethicists, they could make rules about not using it for personal benefits. And then also money could play a huge role in when deciding for who gets it and who doesn't. So having a strict rule where money does not play into it, and then for religious groups there could be laws about who the technology could be used on, so it doesn't affect humans and their religious beliefs. It could be used for other animals, maybe to get more knowledge. And then this would also benefit scientists because it would allow them to get all the knowledge that they need without having to interfere with humans and their morals.
I like that you touched on the economic part of things, because I feel like it's very important to think about whenever we're thinking about this type of technology. You can have people who are extremely rich and can really capitalize on this and make their children genetically gifted in every single way. That can be from things like intelligence to height to a multitude of different things. And this will continue this generational discrimination against people who don't have these specific traits, maybe can't afford it. So making this technology accessible to everybody is very important, although this use of enhancement is very debatable. I think that's something we should really focus on. But also transparency, like making sure that everybody knows how this technology is being used. We know exactly who's capable of using this technology, and just having a very strict, tight regulation of this, because in all stakeholders, all approaches, there is a fear of misuse of genetic engineering, quite similar to the fear of misuse of AI. So in both of these cases, we need to have very tight regulation, a lot of transparency, and honesty when it comes to how these things are being used. As of right now, genetic engineering remains to be a nascent technology, and a lot of its policies usually reside around food. The FDA is regulating the type of genetic engineering that can be done on food, but that's pretty much all we have, because we haven't really delved into the different abilities of genetic engineering when it comes to medicine and actually, changing traits, things of that nature. We haven't been able to do too much human testing besides the ones that weren't allowed, like the Heijangku incident. So while everybody does have a valid approach, I believe that the approach of high transparency
tight regulation and availability for everybody, no matter where your background is going to be the best approach to satisfy all stakeholders in target, or most stakeholders.